Alright, so let's practice some examples of finding integrals using the substitution method. So the first part, so example 1. So let's find the indefinite integral and check the result by differentiation. So we have the integral of x squared minus 9 to the third power times 2x dx. So remember, with integration by substitution, we are undoing the chain rule. So when you're picking your u, you can look at the second page of your formulas. And so in this case, the only one that looks anything like what we have is the integral u to the n du, where n is not equal to -1. So in this case, we want to be thinking about the integral of u to the third du in this case. But the easy way to think about what's going to be your u, think of u as the same way you would think of what your inside function is for the chain rule. So in this case, we're going to let u equal to our inside stuff. So the stuff in this case is being raised to a power. So we're going to let u equal x squared minus 9. So then our next step is we want to then find the derivative of u. So the derivative of u with respect to our independent variable x is du dx. So du dx equals 2x dx. So now we want to solve, so we want to get du by itself. So du then, so we multiply, du over dx equals 2x. So now let's multiply by dx on both sides. So we get du equals 2x dx. And so then notice this is matching what we have left over in our integrand. We have a 2x dx, so du in this case equals 2x dx. Your goal is to always make du match what's left in your integrand. Du should always match. So in this case, du equals 2x dx. That's what's left over in our integrand. So then this equals to, this becomes, when we do our substitution, the integral. We said x squared minus 9 was u. So this is u to the third power, and 2x dx is du. So this becomes the integral of u to the third power times du. So now integrating this, so that's our next steps to integrate. So antiderivative of u to the fourth with respect to u, u to the third with respect to the u, is u to the fourth over 4 plus c, right? Since we're doing a indefinite integral. And then we have to back substitute. So we started with something in terms of x's. We want to end with something in terms of x's. So we back substitute. So this, we knew again, x squared minus 9 is u. So this becomes x squared minus 9 to the fourth power over 4 plus c. Or we can rewrite this as 1/4 times x squared minus 9 to the fourth power plus c. And so that is our antiderivative. So let's check it now. So remember, you should always be checking your problems by taking the derivative, right? If not, you're going to lose points on the test. So let's find the derivative of our answer that we got. So 1/4 x squared minus 9 to the fourth power plus c's derivative. So let's find that prime. So that is 1/4 times 4, so bring the power down. Blah, so the blah stays the same, x squared minus 9. Subtract 1 from the power, so to the third power, times the derivative of the blah, so times 2x, plus now, so we're done with that first term, plus the derivative of a c is 0, because c is a constant, right? And so cleaning this up, that gives us x squared minus 9 to the third power times 2x, which this is the original integrand. if you've done your antiderivative correctly, when you check it, you should always get the original integrand back. So we did. We've got the right answer, and we're done. All right, so let's look at another one. So the integral of the cube root of 3 minus 4x squared times negative 8x dx. So rewriting this, so we know we can rewrite this first so rewrite the cube root of x as just the 1/3 power, so 3 minus 4x squared to the 1/3 power times negative 8x dx. So in this case, our u is our inside function, so think about what would be your blah if you were differentiating. In this case, blah is going to be 3 minus 4x squared, so that's going to be u. So then du dx is negative 8x. So du then is negative 8x dx. Notice this matches what's left over in our integrand, right? So when we do our substitution now, this becomes the integral of u to the 1/3 power du. So now, the goal of this integration by substitution is to always make your integrand easier, and it does. So then let's integrate now. So let's integrate this easier function, right? So the integral of u to the 1/3 power with respect to u, so du means with respect to u, right? So then this becomes u to the 4/3 over 4/3, right? Plus c. And I usually recommend simplifying before you try to back substitute, because it's always going to be easier to simplify using u's than it would be to try to simplify using our actual value that u was, right? There's less stuff floating around to say. So it's going to be easier in this case to simplify first. So the simplifying in this case just means this becomes 3/4 u to the 4/3 power plus c. And so now let's do our back substitution. So this becomes 3/4 u we said was 3 minus 4x squared to the 4/3 power plus c. And we're done. So your last step, make sure you go back and do what? Check it, right? So you go back and check. Alright, so part C. So the integral of x cubed over 1 plus x to the 4th all raised to the 2nd power dx. So same idea, even though we have something that looks like a rational function here, you still want to think of it as the same way as what would your u be if you were differentiating, right? So what would your blah be? In this case, our blah, so u in this case equals 1 plus x to the 4th. So now find du dx. So du dx is 4x cubed dx. So du equals 4x cubed dx. So remember, you want to check and make sure it matches, right? So if we rewrote that integral, the original integrand, well, that would give us the integral of 1 plus x to the 4th to the negative 2nd power times x cubed dx. Uh-oh, it doesn't match, right? So we've got an extra 4 in our du that we don't need. So we got to get rid of that 4. So how can we get rid of it? Divide by 4 on both sides, right? So, and in this case, I'm going to divide by 4 is multiplying by 1/4, just so it looks a little bit neater. So we have 1/4 of du then is equal to just x cubed dx, right? So now what we have matches what's left over in our integrand. So now we can do our substitution. So this becomes the integral of u to the negative second power times 1/4 du, right? Because we only had one x cubed dx. So as always, you can pull the constant out. So this is just the same thing as saying 1/4 integral u to the negative second power du. And so now we're ready to integrate. So this equals 1/4, find then the general antiderivative of u to the negative second power with respect to u. So that's u to the negative 2 plus 1 over negative 2 plus 1, right? Plus c, so that's 1/4 u to the negative 1 over negative 1 plus c. And so that is negative 1 over 4u plus c. And so that ends up being negative 1 over 4 times 1 plus x to the 4th plus c is your antiderivative. So now make sure you go check. And remember to check, what do you have to do? Take the derivative of the function. Alright, so D. The integral of x times sine x squared dx. So now, looking at those antiderivatives, right? Which one does this kind of look like? Integral of sine u du, right? So, and again, thinking along the same terms as what would be your blah if you were doing the chain rule, right? In this case, your blah is going to be what's inside that sine function. So the x squared, so u in this case equals x squared. So du dx equals 2x. Multiply by dx on both sides, du equals 2x dx. So if we look, we've got our sine of blah there. But we've only got one x dx, right? So there's only one of those. We've got 2 in our du. So we need to make 2 turn into 1. The only way to do that is to multiply by 1/2, right? So 1/2 du equals x dx. Now it matches. So this equals the integral of sine u times 1/2 du, or 1/2 integral sine u du. Now we can use our formula. So we know the antiderivative of sine u is negative cosine u, so we have negative 1/2 cosine u plus c, which then becomes negative 1/2 doing our back substitution now. Cosine of u we said was x squared plus c. And you know what's coming next. You're going to check it, right? All right, E. The integral of the cube root of tangent x times secant squared x dx. So in this case, we want to first rewrite our function, right? So this is the integral of tangent x to the 1/3 power times secant squared x dx, right? So in this case, what would be your blah if you were trying to differentiate by the chain rule, right? So which of these rules does this look like? Integral of u to the 1/3 power, right? So think that. So in this case, u is equal to the tangent function. So u equals tangent x. Du equals secant squared x dx, which lo and behold matches what's left, right? Now, what would happen if you think, okay, well, if I was differentiating this, I'd have to do a chain rule on secant squared x also, right? So if you think about that, what would happen if you let u equal secant x? Well, then you're going to have secant x, tangent x, right, inside your du, you're not going to have a way to make that match because you have tangent to the 1/3, tangent x to the 1/3 power, right? So you wouldn't be able to make it match and eliminate all of the x's in your integrand. It just wouldn't work. So you have to let u equal tangent x. So in this case, then now this becomes the integral of u to the 1/3 power. Secant squared x dx, we know is du. And now we can integrate. So integral of u to the 1/3 du becomes adding 1 to the power, so u to the 1/3 plus 1 over 1/3 plus 1 plus c, right? Because we're doing a indefinite integral. So this becomes u to the 4/3 over 4/3 plus c, which then, simplifying, we get 3/4 u to the 4/3 plus c. And the last step, back substituting. Why? Because we start in x, we want to end in x, right? So this becomes 3/4 x, u we said was tangent x. So 3/4 tangent x to the 4/3 power plus c. And as always, you should go back and check it, right? Remember, if you don't check it on the test, what happens? You lose points. Alright, so let's do one more of the indefinite integrals. So the integral of e to the tangent x secant squared x dx. So think e to the blah, right? If you were trying to take the derivative of this, you wouldn't want to let it be secant x because you don't have a tangent x that's not inside of e anywhere, right? And you wouldn't have a way to make it match your du. So let's let u equal what's inside e to the blah. So u is tangent x, right? So du dx equals secant squared x so then du equals secant squared x dx. That matches what's left in our integrand, right? So now we can rewrite by doing our substitution. So this equals the integral of e to the u du. And what's the integral of e to the u du? That's right, it's e to the u plus c. And so then do our back substitution. There really isn't anything to simplify there. So this becomes e to the tangent x plus c. And so let's check it. This is a fairly easy one to check. So e to the tangent x plus c prime. So by the chain rule, that's going to be e to the blah, so e to the tangent x times the derivative of the blah, so times the derivative of tangent x, which is secant squared x, plus the derivative of c is 0. And so that is e to the tangent x secant squared x, which was our original integrand. And so it checks out.